Hi, my name is Samantha and this is my video project. Today I'll be covering implicit differentiation, which is the process of finding the derivative of a dependent variable in an implicit function by differentiating each term separately, then expressing the derivative of the dependent variable as a symbol, and finally solving the resulting expression for the symbol. This may seem quite complicated, but it is actually simple once you practice a few problems. Implicit differentiation can become very useful in finding the derivative of a dependent variable, and is fortunately a straightforward concept requiring the understanding of derivatives. To begin, we must first understand the difference between functions written in implicit form and functions written in explicit form. An example of a function written in implicit form would be 2 times x to the power of 2 minus y equals negative 3. Taking the same function, writing it in explicit form would make y equals 2 times x to the power of 2 plus 3. Implicit differentiation can be used when the dependent variable cannot be separated. For instance, in the equation x squared y plus 4xy squared equals 6 would be an equation in which it is significantly more difficult to separate the y variable. In this case, using implicit differentiation would be very beneficial. Alright, using the equation I just mentioned, you would first differentiate both sides of the equation with respect to x. Basically, take the derivative of each term. However, when you find the derivative of any y term, you must tack on a y prime because this is the dependent variable we will be factoring out and eventually solving for. After differentiating both sides of the equation through the use of the power rule and the product rule, you should have 2xy plus x squared y prime plus 4 times the quantity of y squared plus x 2y y prime equals 0, which can be simplified into 2xy plus x squared y prime plus 4y squared plus 8xy y prime equals 0. In the second step, collect all the terms involving y prime on one side of the equation and move the other terms to the other side of the equation, which will bring you to x squared y prime plus 8xy y prime equals negative 2xy minus 4y squared. Afterwards, factor out y prime and divide both sides of the equation by the left-hand factor that does not contain y prime. The final answer should be negative 2y times the quantity of x plus 2y divided by x times quantity x plus 8y. As you can tell, implicit differentiation is actually quite logical and works beautifully with complex equations. Let's do another example, but this time involving trigonometric functions. Let's say e to the power of 2y times cosine x equals 5 plus sine of xy. For this problem, you need to be able to take the derivative of sine and cosine, as well as being able to use the chain rule and finding the derivative of e to the power of a function. To solve this problem, first differentiate each term. This step is probably the most difficult, so be careful and make sure you write out everything. It will end up becoming 2 times e to the power of 2y y prime cosine x plus e to the power of 2y times negative sine x equals 0 plus cosine of xy times xy prime plus y. Afterwards, you can group all the terms with y prime, factor out y prime, and divide each side by the remaining terms after factoring out y prime. The final answer turns out to be y times cosine xy plus e to the power of 2y times sine x divided by 2 times e to the power of 2y times cosine x minus x times cosine of xy. Now this is the kind of problem that requires an understanding of many aspects of derivatives. Thus, implicit differentiation is a concept that builds upon the knowledge of the basics of derivatives and requires very careful work. Now that you know how to find the first derivative using implicit differentiation, we can move on to finding the second derivative. The only discrepancy in the latter would be taking both the first derivative and the second derivative and later substituting the first derivative back into your second derivative to get the final answer. For instance, find the second derivative for x squared plus 4y squared equals 8. Of course, initially you would go about solving this problem just the way we solved the first few problems. Take the derivative of each term to get 2x plus 8y y prime equals 0. Subtract 2x from each side of the equation, factor out y prime, divide each side by 8y, and you will get y prime equals negative x divided by 4y. But since the problem asked for the second derivative, you must continue and use the quotient rule to find y double prime. Make sure you show your work for each step so it will not only help you keep track of each term, but also reduce the chances of you losing points on tests from lack of work shown. So in this case, y double prime equals 4y times negative 1 minus negative x times 4y prime divided by 16y squared. Since you have already found y prime equals negative x over 4y, simply substitute in negative x over 4y for y prime, and your newer equation should become y double prime equals negative 4y plus 4x times negative x over 4y divided by 16y squared. Through more simplification, you'll get negative 1 times the quantity of x squared plus 4y squared divided by 16y cubed. Something special about using the implicit differentiation to find second derivatives is that you can almost always use your original function to substitute a value in replacement of an expression. In this case, you can replace x squared plus 4y squared with 8, because the original function states x squared plus 4y squared equals 8. Through substituting and replacing the two values, your answer becomes negative 8 divided by 16y cubed, which can reduce to negative 1 over 2y cubed. In these three relatively easier problems, implicit differentiation is used to find the first and second derivatives. This concept is the kind of thing requiring a little practice and an understanding of derivative rules. It doesn't require much deep thought, rather, it revolves around computation and formula memorization. For the more difficult problems, I suggest you thoroughly show your work and make sure all your values have been distributed and factored correctly. Generally, you can't really work backwards to check your work without wasting a lot of time on tests, so you just have to hope the answer is accurate and redo the problem if time permits. Otherwise, good luck, and I hope you learned something new from this video.